Hello, and thank you for joining this episode of DJ Shan Azure Remix. The reason you're seeing me first in the next series of videos is Matt and I actually recorded these videos in 2 longer segments. Rather than have you sit through 45 to 50 minutes of content, I thought I would structure it out so the 2 longer videos are actually 4 more snackable videos. Hopefully that makes sense. If you like what you see, please hit reshare, like, and subscribe for additional content. I've got a lot more ideas and topics to cover. Thanks. Hello, and welcome to another DJ Shan Azure Remix show. This is the next episode in our series on how you teach an infrastructure person how to code. I'm joined once again with Matt Canty, who is a cloud solution architect on the national team. Hi, Matt. How are you today?
Not too bad. How about yourself, Shannon?
I am doing well. I think I'm excited that things feel like they might potentially at some point get back to normal. I think a year ago it didn't really feel like that, but it feels like we might see normalcy at some point, right?
Maybe it still seems a little
I
far
know.
off, you know.
I know. I'm trying the optimism card as much as possible, just because of the fact I feel like it's been a long year for everybody.
Yeah, no, that's a good play.
So today we are going to talk about an overview of ARM templates. And so the idea here is to get you more exposure into what ARM templates are, even though that story is evolving too. And we'll cover some of the changes over the course of this episode series so you can understand the right way to code your infrastructure. So let's do this. Matt, I will share my screen here. And we can start talking about the ARM template benefits. So I don't know, do you want to start talking about this? Because I feel like you've done a lot of this with customers over the course of time.
Yeah, so I've done quite a bit with customers as far as ARM templates go, and I can tell you that one of the major benefits of ARM templates is repeatability, right? So pretend like you have this workload that you have to deploy to multiple environments, possibly even training environments, right? It comes in very handy when say you have a multi-tier application that you have to create some sort of infrastructure for, and you need to replicate that over and over and over, right? Maybe you train different groups of people every week or every other week or every month, and you need to get an environment up and running pretty quickly. ARM templates give you that capability. Some of the reasons why it's a good resource for this includes things like being able to do parallel deployments, right? So if you have to deploy a large number of servers or something of that nature and deploy them quickly, you specify your dependencies within the ARM template, and so anything that needs to wait for something else will wait to deploy, and it'll go kind of in a serial-ish order. But anything that doesn't have any dependencies that are not already created will create in parallel, right? So essentially, I could create 1,000 machines in parallel in just a few minutes, because once you kick off the deployment, then the ARM execution engine will run whatever it can in parallel. And
Right.
so it's a good way to get repeatability and get that very, very quickly.
And I think that highlights the big part of why you would choose to code your infrastructure is consistency, right?
For sure.
We've evolved to the point where we're able to provision infrastructure in a matter of minutes versus a project taking months, maybe weeks to deploy and configure and provision. Everything's codified. And so it becomes an easier reality when you're taking a series of ARM templates or maybe one very large nested ARM template kind of configuration, and you're applying it across different environments. So you've got the same configuration in, let's say, dev, maybe staging and production, right?
Yeah, think about the process that someone would go through before the cloud, right? Even the cloud itself was a huge step. The process that somebody would have to go through in order to provision new, even virtual machines, was They'd
Right.
have to order hardware, right? And then that purchase order goes through this long red tape process for approvals, et cetera, et cetera. And then the hardware actually gets ordered, and then who knows how long that hardware is going to take to get there,
Right.
right? And once it gets there, then it has to be staged into the racks or whatever, however you're getting it set up, has to be plugged into the networking, right? The cloud took care of all of that for us.
Right.
Now we have all this hardware waiting to be used. And so the next step is, okay, you have somebody go in the portal and start creating a network and then creating, virtual machines, one after the other, right? But you still have this manual person sitting there provisioning machines, installing whatever software needs to be installed, configuring them, et cetera, right? And so the ARM templates fit into this area where now instead of having somebody have to click through a portal and configure things, most of it being the same way, right? You have this template that can go and say, hey, give me 1,000 machines that look like this. And it's got the configuration, it's got the networking, all of that type of stuff is part of the template. And so it happens quickly, and you can go off and, do your favorite things like drink coffee.
Exactly. Well, and it helps you better organize the environment, right? You can apply tags. You can think about things like role-based access control, meaning only certain people can deploy these templates into production. These are kind of the blessed templates, so to speak. Everything's been tested to that point that once it deploys, it will be up and live and functional within a short period of time. And then it also kind of helps you with cost management too. The idea that you can think about defining things within the template where, and we'll talk about this, where only certain types of resources can be deployed. And if somebody's not familiar with the ARM template, they may get a question mark when something fails, right? There's ways to sort of control your environment. There's ways to organize your environment, and you can provision your environment very quickly as a result.
Yes, and one of the newer things that I've been working on actually with a customer is to deploy an ARM template in the case of like a policy violation, right? So you have Azure policy as well, right? And that's what you set up to kind of put guardrails around your environment so that you can say, hey, Joe IT guy or Joe department head, here's your subscription, go and create whatever you want. But we have all this policy that's going to govern the things that you can and can't do. For example, maybe it's creating public IP addresses because we can't just have, anybody in the organization create a public IP address and then, give that, some sort of attack surface into that subscription and maybe even into the entire environment if you're connected to your on-prem, right? So you have policy that you can put the guardrails up for things that people can and can't do. So that's a layer, even central IT, more of a central IT layer than what you would have in ARM templates. But as a remediation for a policy violation, you can say, hey, if somebody deploys this thing and maybe they don't have a log analytics workspace deployed or something of that nature, you can say, oh, if this is done, then run this template to make sure that whatever we need, whatever resources we need to deploy are deployed. And so I was working with a customer this week about, how to kind of respond if somebody maybe creates a virtual network that doesn't have the right DNS servers or things like that.
Which is kind of cool because if you think about it, there's still kind of a mixed, I guess, skill set, right? Devs understand infrastructure as code. Ops folks are a little, I don't even know if the right word is they're sort of hesitant. They need to understand it a little bit more. Also, folks feel a little like, why am I learning this? Right. So that's kind of cool that you can apply code to make sure your environment adheres to the same standards that you'd want your organization to lean on. Right.
Yeah, and think about it this way. The ARM template language, you're not writing procedural code like you would with some
Thank
scripting
God.
like
Right.
PowerShell or Python or something
Right.
like that, right? This is more closely related to what an infrastructure person would do in a configuration file, right? You have a configuration file and hey, this property, I change it to this value, and this is the way the software is going to act based on that configuration. And so ARM templates are a lot more closely related to a configuration file than they would be to say PowerShell or Python or JavaScript or some sort of scripting language that you would try to
Right.
use to automate something.
Right. Right. Let's talk a little bit about what ARM templates can do. right? And I think we've hit on it, right? The idea it can define infrastructure, you can define the configuration, and then you can maintain that consistency. And I feel like you've got a great talking track surrounding parameters, variables, resources, and outputs. So I wanted to make sure that you had your opportunity, because I remember when we worked on the same team, you had written a really powerful blog post. I think it's still up. And what we'll do for this video is we'll link it in the actual description, right? So that somebody can go and read it. But I feel like you've got a really good way of describing this, right? Because there's specific sections in an ARM template.
Right. Yeah, and really, so when you think about your ARM template, the most important thing that you're putting in your ARM template are your resources. These are the things that are going to be deployed. Now, when we talk about item potency, like we talked about in the last episode a little bit, that's where we get into, okay, well, no, we don't want to hard code everything within those resources. Like if I want to create a virtual machine or a bunch of virtual machines, I don't necessarily want to have to write a new template for every virtual machine, right?
Right.
So what are the things that are going to change from deployment to deployment on these virtual machines, or from creation of a machine to creation of a machine, right? So things like the machine name is going to change. So you're going to want that to be defined somewhere where it can be changed. Things like the machine size are going to change from deployment to deployment. And it might be, the image that's used with the machine, or a number of just different things that say I need 1,000 machines, but they all don't look the same.
Right.
So we define those things that will change within the resource itself. We define those as variables or parameters.
Okay. What would be, so when you have these conversations, and I think you and I are probably on the same page, but I think this is helpful to kind of describe, when would you pick a parameter versus a variable, right? There's probably a little bit of logic that you'd want to leave folks just understanding between the two.
Certainly. So here is the main difference between parameters and variables. Variables are set within the template. So what I use variables for is possibly doing some things like creating a resource ID to reference against, right? So if let's say I have secrets that are in a key vault, right? And I don't want somebody to have to put in a key vault ID, right? Because that's buried in the portal. You got to go find the properties, you got to go find the ID of the key vault in order to reference that key vault to get the secret. So I'll say, okay, put the resource group that the key vault's in, put the name of the key vault, and then what's the secret that you want to reference from that key vault to pass into the template, right? Well, I will define the three things that I want them to provide as parameters because those show up at runtime, or you throw them into a file. And then I will reference those in the variables to say, concatenate these things together along with this string in order to make this the resource ID of the key vault that I'm referencing. So they don't have to piece all that together. They just say, oh yeah, it's in this resource group. It's got this name. This is the secret name that I want to reference. And voila, it's it kind of magically creates the string that they need in the variables. So variables are things that have to be changed by modifying the template. So those are things that may change, but they're not going to change from deployment to deployment to deployment, right? However, parameters will. So when somebody runs this resource template, they are going to provide a set of parameters.
Right.
And that set of parameters is going to change probably every time you run it, unless you have to rerun it because you're adding more infrastructure, or maybe you had a failure or something when it ran. You have to rerun it, and then it's going to run with the same values. But most of the time, user A is going to run this template. You don't want to have to create a new template for user B, so you'll use the same template because they want a similar environment. Just pass in their own parameter file, defining the parameters that they want to name their machines and all of that type of stuff. And then variables, if you have standards, like just different options on resources that might like require HTTPS, that might be a standard, might not be a standard, but you can put that as a variable, and then the author of the template goes in and changes that variable when the standard changes. That's one example of how you do that. But most of the time, I use variables to concatenate things together, or make decisions based on the parameters that are being provided. So I can say, I can give the person running the template an option of saying, provide your OS, Windows or Linux. If
Right.
they pick Windows, then I have a variable that says Windows equals this specific image out of the gallery. If
Ah,
they say Linux, I have my variable that says this is the specific Linux image that I'm going to use out of the gallery. So they only choose Windows or Linux. I set the standard for what image they're going to use for this deployment.
I think you'll appreciate this story. When I first started with ARM templates, I didn't have a Matt Canty in my life. So let's start there. But the idea of hard coding things always felt safe to me. And that's just, I'll blame that on my infrastructure roots. So I used to place everything in my variables section, which is a massive no no. But if it gets you more comfortable with staring at lines and lines of code, it's something to do temporarily. But I think the big piece, especially after working with you, Matt, was realizing that your parameters really can be and maybe should be a separate file entirely. And you can always call upon that when you're building your environment because that'll have all the parameters that the main template is looking for.
Yeah, so here's a little tip. If you want to define something in the resource that is going to change, you can always define it as a variable. If you want to set that at runtime, you can tell that variable just to go up and pick this parameter, right? So at the least, set your values that are going to change from your resources to a variable. And then in your variables, when you define that variable, you can say, oh, by the way, just point at this parameter. So you can just have your variables referencing parameters, and that gets you a lot more interchangeability than just hard coding stuff into
Yeah,
the
agreed.
resource.
Agreed. So outputs is also listed on here. We're planning on digging into that, but do you want to talk a little bit about why you would put an output into an ARM template?
Yeah, so outputs are really valuable for when you're using nested templates. So that's the biggest use case that I have for those is if I use a nested template and I call a deployment and then I need to reference something from that deployment in another deployment that I'm doing, I will reference the output from that deployment and then bring that in as a parameter to a deployment in another nested template that I'm doing. So this is all within like the same main deployment, but I'm running this template. It's going to do this thing, and it's going to spit back maybe a URL, maybe an IP address, maybe just a reference to a specific resource, so that I can then now attach this resource to that resource, or things like that. So outputs are really there so that you can, and I also use them for testing to see, hey, if I did this, what kind of output would I get from maybe it's a concatenation of a string or some sort of math type of function that I'm doing within my templates. So then I'll say, okay, just as a test, what's going to happen if I use this and do a little bit of math here, and like if I'm trying to figure out how do I piece together different subnets within a VNet's address range. There's a lot of string manipulation and math that you can do in there to try to piece together subnets and things like that. But the best way to test that is just to get a blank template, put your variables and parameters and things like that in there, and then do the math in the variables, and then use that as an output to the template. So you don't deploy anything, but you get the output to say this is what your IP address would be for this, this, and this. Right? That's
Yeah.
one of the use cases that I've used outputs for, just for testing.
Yeah, and I think when I was first experimenting with this, I had that as the public IP for my VPN gateway, right? I never wanted to go back into the portal unless I absolutely have to, because I'd always set up like a VPN for my house. And I wanted just to know what that public IP was rather than going into the portal, going into the resource, and then figuring out exactly what the IP was. It was a faster way to get the info I needed. That was another way I chose to use outputs.
Yep, exactly.
So let's talk a little bit about the terminology, right? And I think if you're watching this video, you probably know what a resource and a resource group is. That's been very common vernacular inside the Azure ecosystem for quite a bit, especially given the fact that that's a great way to group everything, right? You have your resources, you put them into resource groups. It's all your metadata surrounding whatever you're deploying. Some folks don't necessarily know what a resource provider is. So, Matt, do you want to talk a little bit about that? I feel like you've got a great way of explaining what that is, just because I feel like and even if folks know what it is, I think Matt's got a great way of kind of talking this through so that folks understand.
Yeah, so resource providers came about when Azure Resource Manager was born, right? So before Azure Resource Manager, we had what was called Azure Service Manager, right? ASM, and this was one large monolithic API for all of Azure. So imagine with all the services and resources that we have out there now, if that was in one monolithic, API to call whenever you wanted to do anything, imagine having the Azure product group try to change something. Every time you change something, you have
Yeah.
to redeploy that whole API, right?
Right.
So resource provider was a way to split up your APIs into multiple providers per resource. And that's based on what type of resource that is. So like your examples here, say Microsoft.storage, that would be things like storage accounts and all of the things that go along with that. It could even, sometimes the resource providers include like the RBAC roles for those things.
Yeah.
And then you have Microsoft Compute, which is like virtual machines, virtual machine scale sets, anything that might have, compute behind it. You'll have Microsoft.network. So this provide it's really the API that you're calling, but it's split up into multiple APIs so that if one group has a new service or a new feature that they want to add, they can just update their resource provider and not have to affect the deployment of all of the Azure resource
Right.
providers. So that was really the kind of the driver behind Resource Manager and having resource providers, is just because when you manage something as large as Azure and it's software based, you got to do updates, and this is how we do updates without having to spend hours or days. I mean, at this point, maybe even weeks, as large as Azure is now,
Right.
to deploy something to make a feature change, right? And it
Right.
allows those teams to move at their own pace versus, okay, we got this feature for the next update, but we have to wait until this group and this group and this group all have their features ready, right? So it gives them a little more autonomy around their deployment of things.
Yeah, and then we've definitely touched on ARM templates. So think of that as like your recipe for what you actually want configured. And there's so many different ways of specifying that configuration within an ARM template file and a parameters file, for instance. And you can think about even making that more complex, more vast by doing things like nested templates. And we'll talk about that later down the road. But that is kind of the guide for what gets deployed. And ARM templates themselves use declarative syntax, which we've hit on. Matt, I forget, did you go into that the last time we had a conversation? Do you want to just do your
Yeah,
little
yeah,
full
we went up
spiel?
yeah, sorry. We went through declarative versus imperative
Right.
programming, right? And so declarative syntax basically means that you have a way of declaring what you want versus a way of procedurally, deploying what you want step by step by step by step, right?
Yeah.
So you can provide this one big, large declarative file that says, okay, I've got a machine in here, and you might be doing copy loops, you might be doing other things in there, but it declares to basically give you a picture of what you want versus having to just procedurally go through and write, I want this, and now I want this, and now I want this.
Right. Right. So wanted to hit on that as well, just because I feel like it's something that, as you become more skilled in the realm of ARM templates and infrastructure as code, you might see declarative syntax. So I wanted to make sure we hit on that once more.
Yeah, and it's pretty big because you don't have to worry about the implementation. You are only worried about what you're trying to deploy, so you're only worried about what it looks like. That's where declarative becomes powerful because you don't have to worry about the implementation or how it's done in the background. You just worry about what you want it to look like.
Yeah, so let's dig into the format of an ARM template. I think this sometimes gets folks a little anxious, right? So it's JSON, right? And it's a key value pair. The data is separated by commas. Curly brackets hold the objects. These square brackets hold the arrays. And these are probably terms that might feel a little foreign to an infrastructure person. So, Matt, when you work with customers that are trying to become more skilled up in the realm of infrastructure as code, how do you start to describe this, or at least get customers more focused on what the JSON is actually doing related to the infrastructure that's being deployed?
Yeah, so JSON in and of itself is really almost self-explanatory. It is a human readable object format. JSON stands for JavaScript Object Notation, which basically means this is the way of describing to JavaScript what an object is supposed to look like.
Uh-huh.
And that is, the object has these properties, and those properties are specified in key value pairs like you mentioned here. And for those properties that might have a group of things, right? That's where you would use an array, which is just a group of things, right? It could be a group of strings, which is just then you comma separate a string from another string from another string. It could be a group of objects. And so that object might also have multiple properties, right? So that's where you would have curly brackets, open and closed, separated by commas. And so the sets of curly brackets represent the number of objects that you have in that array. And one question I was going to ask you is, do you know why we use JSON format for ARM templates?
That's actually a good question. I don't know. And I feel like I should know at this point. And shame on me for not even thinking about this, because I feel like that's a good why question. I don't know.
Okay, and I think you do know, you just don't know that you know. So,
Thank you for
so,
being kind to me.
so the work that we've done when we've been calling APIs, right? We've done some work calling APIs. You
Okay.
and I have in PowerShell,
Yeah.
right?
Yeah. And then you're getting the JSON response from the APIs.
Exactly. So JSON is the most popular format to use when passing objects between APIs. Usually you'll put a body of JSON into your request, and then if your request requires a response of an object or whatever, if something's being created in the background, then that object will be also output in JSON.
Got it.
Otherwise, a lot of times you just get like a HTTP code to say, yes, this was created, or an error code, of course. But that's why we use JSON format, because when we write an ARM template, we are writing the body of a request that we are making to the template execution engine to say, hey, Mr. API, we're calling that ARM API and saying, I want this created. Here is the body of what I'm creating. And that body is expected to have specific key value pairs, right? And so that would be your objects or your resources that you're creating. And then those resources would then reference your variables and parameters and things.
That's so crazy. I don't know why I didn't even think about that, because I know you and I spent a lot of time where you actually showed me how to use Postman. We'll talk about that at some point down the road. And you had shown me everything related to the JSON payload. I guess I didn't really make the comparison that that's really why we have ARM templates codable in JSON.
Exactly why, because we're just calling an API.
Makes sense. So yeah, so down here the key is kind of always a string enclosed in quotation marks. The value can be a string, which is it could be just the name of a VM. It could be a number, an integer. It could be a Boolean expression. Matt, what would you call a Boolean expression?
A true false value.
Okay. And then the array is that group, and then the object is how would you say it's a little bit larger than the group, the array, or the object is, right?
So yeah, the object is really just another, I guess I would call it another key or another value, actually, a group of values.
Okay.
An array, if you have an array, the values inside the array are expected to be the same. So if you don't really put a string into the same array as you would put an object or a number.
Got
right?
it. Okay.
Some languages will implicitly turn numbers into strings if it knows that it's expecting that to be a string array. It will see a number and say, "Oh, I know how to convert that into the number two, in a string format." But a lot of times you'll get errors when you try to put different types into the same array.
Okay.
And so that's why we use objects, because then that object encapsulates all of those values into a specific type of object.
Yeah, and then the key value pairs are, a specific syntax that, where you've got the key followed by a colon followed by the value. So the idea of this being very kind of comma separated, it's an interesting proposition. And I think when I first became more familiar with it, I'd miss a comma here and there, but it became very evident very quickly where the commas had to go in order for the ARM template to be kind of provisioned inside of Azure.
Yes, and when you are writing ARM templates, especially, be aware of what type of value that is being expected for what keys, because if you provide a string where you should provide a number, and that means if you think, oh, I need something in quotations for the key, and then a colon, and then something in quotations for the value. Well, if that value is not a string, if it's supposed to be a number, you actually don't put that in quotes. You put the number without quotes around it, and then a comma to go to the next key.